Let's talk about JiBase. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Between the previous video and this video, I sat down and wrote a whole library without recording anything. Honestly, it was nothing big and it was called JiBase. Now JiBase has some annotations, we can take a look at that. And actually right now I'm using it here on itself. And these annotations most of the time are being used to annotate something like the class. And when I move my mouse on top, you see that I have annotations and these annotations are giving me information. Other than the annotations, I have the constants moved into the JBase. Now, some of these were in the reference class, some of them were for the logger class. I made the decision that, you know what, these constants can sit here inside the JBase. Then we have enumerations. IO status right now is not being used in my libraries. However, think about any machine or any slot or anything actually that can have input, output, both of them, and no functionality. Then the mapped direction is actually here. We talked about it before. And I added something that is called tick status. Now, tick status normally belongs to the tick logic library. And honestly, I may move it there, but I think I keep it in the base because I'm not sure if I will use it in any other circumstances. And having it here doesn't harm anyone. Then we have exceptions. In the exceptions, I have an exceptions class, throw CTOR assertion that throws init CTOR exception. Init CTOR exception is just an exception that we can throw at the constructor of classes that shouldn't be instantiated, like mod blocks class. Then we have functions. Now these are mimicking the functions that comes with the Java. For example, we have tetra consumers, we have tetra functions and tetra predicate that are just predicates, functions, and consumers, but with more params. And I go all the way, I think, to 9. I'm not sure, but I think it was 9 params. Then we have some interfaces. Now, some of these interfaces were inside Jiralibs, like IBE factory, IBE screen is something new, and iField getter, iField setter, iSpread, iStorage connector. Some of these, like iTick logic and iUpdatable, were definitely inside Jiralib. Some of them may be used inside inventories, some of them may be used inside fluid or energy libraries. However, now they are all sitting inside the JBase so that I don't have anything to do with them. Again, properties for BE properties, block entity field and fields, properties and properties BE, state properties and state property were moved into JBase. Finally, we have utils for base helper, mat helper, position helper, and transfer helper. Now, let's go back into components. This was something that I found on Industeria repository from Turtivorti. Honestly, the more I looked into their code and the more I looked into what Turti was doing, I saw that it's way too complex and overcomplicating some concepts that were already implemented in an easier fashion. So although the component container is a nice thing to have, I will drop the synced component and the updatable component. Now, component container will sit there, iComponent will sit there, and chances are that I will never, ever use them. Now that I removed the updatable component coming into interfaces and iTick, I think it was iUpdatable, sorry. I don't need to return a boolean now. It's void now, and the default is just empty like so. And that would be the updates on the JBase library and anything that goes into the JBase library. Things have changed and will change again in this video. Now, the G block is now having a codec, a map codec that is sitting on the block itself. From 1.21.5, every single block should have its own codec. The way we will use it is to add a codec into the constructor calling the create codec. For example, let's say that this is an arbitrary class. We will say codec equals to create codec, and we will send in the class constructor here as the function, okay, as a factory. And without the need to putting the codec again into the class, we have it. Also, this properties was final. Now, it's not final because in the classes that are depending to the library, we may want to rewrite these properties from scratch inside the constructors, and being final will hit us back. Okay, time to this thing. I remember that I had something else here. I had this dot state manager equals to blah, then update the state manager blah. These two lines caused an error when I made the main mod depend on the G block, and I tried to run the game and I got this error: Java lang illegal access error. Update to non-static final field state manager. Now the thing is that at the time I was using access wideners, and I thought that if the Jiralib is using access widener and giving access to this state manager, extending my blocks from G block will cause no problem. However, that means that inside my main mod, for example the Ultra IO, I had to go and add the access widener into the build.gradle and then into the access widener file here, and again make the state manager accessible inside Ultra IO mod. This is something that I don't like, because the users of library shouldn't be forced to have an access widener and reference an access widener. That makes absolutely no sense. To fix it, now we are using mixin. I'm aware that at the time of recording, I didn't talk about mixin in the channel. Well, this video will be much later in the channel, but I'm recording it at least 4 to 5 months earlier than the publishing date. So maybe at that time we talked about mixins, maybe not. But here's the thing, I'm using a mixin on block class, and all I'm doing is that I'm saying that the state manager is mutable. However, because I want to get access to the state manager and assign a new state manager to it, now I have to use an interface, and back into the block I say that, hey, this block is an instance of that interface so that I can call the state manager. That is exactly here, set the state manager, and that is equivalent of this line. Finally, I can say set default state, and I don't need to update the state manager anymore. So this made me get rid of the access widener usage. Now, the access widener usage happened 2 times in the libraries. One was in Jiralib, and I don't remember where else did I use access widener. Maybe in JiBase, I'm not sure. In both cases, actually, I'm using the same mechanism to make a field accessible using mixins now. Then we come down until we hit this place, on state replaced. Now, honestly, this is making me confused. If you look at any other tutorial related to the inventories on the block entities, you will see that they are checking on state replaced. However, this code will fail. The reason is that block entity equals word.get block entity at position. Well, guess what? When the block is broken and when we are calling the onState replaced, we already removed the block and the new state of the block is now air. So when we look into the word and try to get block entity, the block entity of air will be null. So this check will fail, and because it's failed, we can go into this line. Now, if you look at those tutorials, some of them are mentioning that you need to call this super because the super is responsible of breaking the block. If you look at onState replaced on the block class, you see that in the structure, we don't have onState replaced because it's from abstract block, and inside abstract block, onState replaced is now empty and the block is not overwriting it. So no block breaking is happening there, meaning that the main and correct code should be on break. This will be called whenever we are actually breaking a block. And if you have watched my video on the block entity inventories, you will see that we are handling it there. We did try the onState replace, it failed, and onBreak is working. Now, because we are breaking the block, we are sure that we are already breaking the same block that we are working on. So we don't need to check any states there. All we want to do, we say if the word dot get block entity at the position is instance of Now we want to do something here, and the instance should be something that is responsible of dropping items. The thing is that I don't have any way of finding it because the JBase is carrying lots of the interfaces, and right now I have nothing related to the items and things like that to be dropped. And I can add the interfaces for inventory, but I will prefer not to do it. However, here's the thing, the G block shouldn't carry the inventories. So if you want to carry the inventories, you need to have an extension of this guy. So this part will be removed and I will drop it. I will use it somewhere else. However, I will keep it here because of this single line of code. And when we finish the other library, like the inventory library, we can come back and behind the scenes, I will drop this place from here to here. I will keep the multi-block because, as I said, I'm not working on the multi-block right now. I don't know if I want to even touch it or not. And because of that, right now we are not doing anything. Also, because I dropped the concept of components, I will remove this to do from both places. And honestly, the component container will be a helper class that others can use and I will not use myself. Now, the next thing is this. When I dependent my mod into G block and I tried to use the block, I got a null point exception because at some point we have a block that doesn't have any block entities, or the block entities properties doesn't have anything else, or the block properties doesn't provide the block entity properties yet. So I did add another check here that says if the properties dot block entity properties is not null, then try to look and see if it has a GUI or not. So that's an update there for you. Also, here we had a call for the super. I removed that and I directly sent in back success, because if we fail anything here and we come back here, the super was returning pass, means that our hand wouldn't animate itself like it's clicking on the block. If anyone was watching us, it would look like we are staring at the block without doing anything. So instead of calling the super, I return success so that my hands would be animated. And that is related to G block right now. Finally, G inventory and finish what we have to do. Let's talk about what we have here. We have lots of add inventory calls being added to the inventory connector. The reason is that I was testing the possibility of usage inside a mockup test file, and I noticed that at some point I had a problem. Although, as you see, I didn't keep that test. I wish I had. But the thing is that when you want to add a recipe inventory or a simple inventory, and you call that recipe inventory : new, none of the above would work. But having a factory will actually work, because now we can say that we want a size, and the size were provided before. Same goes with decided and for map direction and direction. Then we can have an overload that we send in the items with the factory. So the usage example would be something like this. Let's say that at any time in any block entity, we have an inventory connector of type simple inventory. Okay, it doesn't actually, let's go with the recipe inventory. So recipe input inventory, and we call it test. Okay, equals to new inventory connector. Now, if I want to add a new inventory to this, we say test dot add inventory, and I want 7 slots in the inventory, and then I want something like this: recipe simple inventory : new. Now, before we couldn't do this. We had to say that, hey, add inventory, new recipe inventory of size 7 and stuff like that. But now we can do it. And if I middle mouse click on it, you see that it's calling this overload. This works for recipe and simple inventories. And all these overloads are just different ways of handling it. As you see, one of them is using map direction, one of them is using direction, an array of item stack, and then the array with the directions. Then we have these ones. These ones are related to synced output and predicate, because these 3 inventories are actually asking for the block entity as a param. So again, we can have the same concept that I showed you as an example here for these ones. And honestly, I think I will not remove everything, and instead of to do, I will keep it as a comment here and this one as a comment here. So those that are starting with block entity are for the synced output and predicate, and those that don't have block entities are for recipe and simple. That was one update. Then we have this one, and it comes from iStorage handler inside inside the base, I think. Yes, it has the add storage. We already had few of them as overrides from the storage connector, because storage connector is actually writing the I storage handler. And then we have the implement in the storage connector. We have this I storage handler, and you see that we have this get storage, and we need to add this add storage. And honestly, let's see, we have public void add storage, the I inventory storage. Let me copy it from here because it's bothering me right now into here, and instead of this already have an implementation close to this one, and that's this guy. However, I storage handler, oh yeah, it's the same thing. So it's T, and we have the direction. Yeah, I did already added it. Okay, I already had added it. So I added this into the I storage handler here to have the direction side by side, the map direction, and I had to add it inside the storage connector. So now that the storage connector has it, I don't need to overwrite it inside the inventory connector. And that would be it. Our inventory connector is actually finished and ready and complete. However, I want to go beyond this. If you recall, inside Jiralib, I had this client abstract screen handler. Now I need to go above it and do something beyond that. We will have two more packages. One is client and one will be block entities, so BE. On the client, I will have a Java class. Now I won't call it abstract, but I will call it inventory screen handler, and yes, add it please. And this will be extending the abstract screen handler. Now abstract screen handler needs the generic of T extends block entity, and here I will send in the T to solve that problem. Now it says implement methods. Now it asks for add a slot, get inventory size, get valid blocks. I'm not going to add any of them. I will make this class abstract. Okay, and now it should yell at me to create the constructor. Now the constructor that we want is the block entity and the other one. However, I didn't add the repository to the Maven. So I will stop this class right here, right now. And I will add another class inside the BE, and I will call it inventory block BE, but J inventory BE. Why not? Now this one will extend the synced block entity, and honestly I will stop right here because it will need generics. And if I remember correctly, first of all, let's call it synced BE properly, and this one needs T that extends the J inventory BE, and here we send in the T, and of course here we need T. Okay, now we create the constructor matching super, and this one is working right now, but there is a reason we are having it, because we want to add the inventory connector on top of it and handle things on top of it. Also, I will have a package called block, and inside the block package, I have a new Java class calling it G block inventory, and this one is extending the G block. So now it is telling me to create the constructor. That's okay. Now this one will handle the inventory stuff. For breaking the block, the screen handler will draw the inventory, and the block entity will handle the inventory inside the block entity. This will happen in the next video. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.